3.3 is about the product and quotient rule. And other than memorizing these rules, the most difficult part is to identify when to use them. The product rule is when you have two differentiable functions, that means you can find the derivative of them, and they're being multiplied together. So notice if I'm taking the derivative with respect to x, then both of these functions have to be functions with x's in them. And if you're multiplying two things with x's in them, the product rule says take the derivative of the first times the second plus the first times the derivative of the second. So when you're using the product rule, you're identifying your f and your g, the two things you're multiplying, and then you take their derivatives and the functions and multiply them together that way. So this first problem, h of x is 5x to the 7th plus 5x times 6x cubed plus 3x squared plus 3. That would use the product rule because I'm multiplying two functions of x together. So I'm going to call the first one f, and the second one I will call g. Now from the product rule, I also need the derivatives of f and g, so I can put together the derivative of f times g plus f times the derivative of g. So if I'm working out the derivative of f of x, f prime of x is going to be the derivative of 5x to the 7th plus 5x. So the derivative of 5x to the 7th is 35. 7 times 5 is 35. X to the 6th plus the derivative of 5x. The derivative of x turns out to be 1 times x to the 0. And x to the 0 is just the number 1. So the derivative of x is just 1, so that becomes 5. The derivative of 5x becomes the number 5. I have to do the same thing for g of x. So the derivative of g of x, the derivative of 6x cubed, 6 times 3 is 18, x squared. The derivative of 3x squared, 3 times 2 is 6, x to the first. And the derivative of 3 works out to be 0. So I have f and g, I have f prime and g prime. Now I can find the derivative from the product rule. The derivative of my function. That's h prime of x, because my original function was called h. So the derivative of my original function is f prime, that's 35, x to the 6th plus 5, times g, which is 6x cubed plus 3x squared plus 3. So there is f prime times g, then there's a plus sign, and then we do f. Well, f was 5x to the 7th plus 5x times g prime, and g prime is 18x squared plus 6x. And at the moment, that's good enough for me. You don't have to go and simplify that any further. When you're using the product rule in the beginning, I just want to see that you can actually put it together correctly. So that's how you would use the product rule to find the answer to that. There's another way to do it, however. In this case, I could have multiplied those things together, and I wouldn't have needed the product rule. I could have FOILed it all out and just took the derivative of each term. And that would have been another way that you could find the derivative. It would have looked a lot nicer when you were done. However, you'd have had to multiply those things together to do that. So let me just show you really quickly the other way you could have done this one. Sometimes you can get around the product rule by actually multiplying them together. Now, it doesn't necessarily make it easier or harder unless you're solving equations. So in this case, if you wrote that as your answer, you get 100%. However, I'm going to do this the other way. I'm going to actually multiply these two things together and then take the derivative of what I get after that. And I'll get the same answer as I got above, except it's going to be simplified. So what do I get when I multiply these together? 5x to the 7th times 6x cubed, that's 30x to the 10th. So let me write this below so I have room. So I'm just multiplying it out so I don't need the product rule. 5x to the 7th, 6x cubed, is 30x to the 10th. 5x to the 7th times 3x squared is 15x to the 9th. 5x to the 7th times 3 is 15x to the 7th. Now I'm going to go to the 5x. 5x times 6x cubed is 30x to the 4th. 5x times 3x squared is 15x cubed. And 5x times 3 is 15x. I haven't taken any derivatives yet. I just multiplied those two things together first before I took the derivative. So if you look at how h of x looks now, I can take the derivative without the product rule, because I'm not multiplying together two functions of x. All these functions are being added. So in this way, I can just take the derivative using the power rule. 10 times 30 is 300, x to the 9th. 15 times 9 works out to be 141. Oh, 15 times 9, I'm sorry. 15 times 9 is 135, x to the 8th. 15 times 7, that's 105, x to the 6th. 30 times 4, that gives me 120, x to the 3rd. 15 times 3 is 45x squared, and the derivative of 15x is 15. If you were to FOIL together your answer in way 1, you would have gotten exactly the same answer as we got way 2. This is way 1 using the product rule above. And this is not using the product rule. This one just multiplied it all together and found the derivative. But if you multiply your answer from the first one, you'll get what you got in the second one. Remember, on the test, some of these you'll have to use the product rule on. I'm not so concerned that you simplify that. So you could leave it as with the product rule answer completely. Let's look at another example of where we would use the product rule. Here's another example of using the product rule. And again, here, if you wanted to, you could multiply those two things together and then find the derivative. Completely legitimate. But in this case, we'll do it with the product rule. So I'll call the first one f of x. Well, in this case, I already have an f of x, so I should probably be careful. If I go and call this f of x, notice the original function is f of x. So it's probably a bad idea to go repeating names. So let me call it u and v. And this is another way that some people think about the product rule. Since people usually use f of x to name the functions, sometimes it's better to remember the product rule with u's and v's. And let me show you what it would look like with u's and v's, just up at the top really quick. The derivative with respect to x of u times v would be u prime v plus u v prime. Notice I just replaced f's with u's and g's with v's. That's the only thing we did. But it's the same product rule. It's just easier to remember the functions or identify the functions that way. So the derivative of u, well, first let's rewrite u so it's easier to find the derivative. That's 1 plus x to the negative 2 power, because the x squared is on the bottom. So when I take the derivative of 1 is 0. The derivative of x to the negative 2 is negative 2 x to the negative 3. By the way, that's the same thing as negative 2 over x cubed, because the 3 is negative. My v is x squared plus 1, so that means that the derivative of v is just 2x. So now I can use the product rule to find the derivative of my function. Remember what the product rule says. The product rule says the derivative of the first times the second. The derivative of the first is negative 2 over x cubed times the second, which is x squared plus 1, plus the first, 1 plus 1 over x squared, times the derivative of the second, which is 2x. Again, I'm not concerned about simplification. You just need to be able to identify the functions, find the derivatives, and put them together in the right way. So in one more product rule, it's the exact same idea. Here I have an f of w. So again, I'm going to identify things with u's and v's because it's easier. I'll call the e to the w u, and I'll call w cubed minus 1v. Well, the derivative of e to the w is e to the w. And the derivative of w cubed minus 1 is 3w squared. So I can quickly use the product to find the derivative of my function, the product rule. And the product rule, remember, if we look back up on the top, it's the derivative of the first times the second. By the way, since there's a plus sign in there, it doesn't matter which way you put them in. But if you continue to take more math classes, when you get things called the cross product, that does matter. It's later on. For all this course, it doesn't matter which way you put them together. But I'm going to do the derivative of the first, that's e to the w, times the second, which is w cubed minus 1, plus the first, u, which is e to the w, times the derivative of the second, which is v prime, which is 3w squared. And you can expand that and simplify it in lots of ways. But again, I'm just concerned that you can show me you know the product rule and when to use it. The hard part is when to identify it. The other topic in this section is the quotient rule, and quotient means divide. So if f and g are differentiable, that means you can find their derivative. Then the derivative of f divided by g exists as long as the bottom isn't 0. And the reason the bottom can't be 0 is because it's undefined there. And so the quotient rule can be difficult to remember. You have to be extremely careful with the quotient rule because of the negative sign. The negative sign in the middle means you have to be careful that you put the right stuff first and the right stuff second. And there's lots of ways to do this. One trick that people use to memorize it is low d high minus high d low. The low is the one on the bottom. The high is the one on top. And when you say a d, you mean derivative. So low d high means the bottom times the derivative of the top, minus high d low, that means the top times the derivative of the bottom, divided by low squared. So low d high minus high d low over low squared. People try to find many ways to memorize the product rule, and or the quotient rule, and really you just try to find the way that works the best for you. Now again, a lot of times people use f and g, so another way you can think of this rule is with u's and v's. Sometimes people do it with u's and v's because functions aren't always named with those. So if I have u over v, the derivative would be low d high minus high d low over low squared. Same product rule, except I use u's and v's instead of f of x and g of x. So same thing as same quotient rule, except I use u's and v's. The same idea as the product rule, though. Identify your functions, put them together in the right way after you find the derivative. So first we'll look at this one here. Here, the function on top, I'm going to call it f, is 12s cubed minus 8s squared plus 12s. And the derivative of that thing, 12 times 3 is 36s squared minus 16s plus 12. The one on the bottom I'll call g. That's 4s. The derivative of 4s is just 4. So now I can use the quotient rule to find the derivative of my original function. It's low, which is 4s, d high, that's the derivative of the top, 36s squared minus 16s plus 12. So that's low d high minus high, that's the original f of x, that was the one on top, 12s cubed minus 8x squared plus 12s. That's high d low, and the derivative of the bottom is 4. So low d high minus high d low, all divided by the low squared. And again, I don't care how much you simplify it at the moment, because I just want to see that you can identify the function, find the derivatives, and put them together the right way. But there's another way to do this problem. So just for full disclosure, way 2 to do this problem is you could actually divide it first. You can rewrite this as 12s cubed over 4s minus 8s squared over 4s plus 12s over 4s. I can do that because the denominator is the same, so I can add the fractions together. And when I simplify this, I get 3s squared minus 2s plus 3. All I did was divide. I haven't found the derivative yet. But in this new form, it's easy to find the derivative because I don't need the quotient rule anymore. I divided first. And in this case, the derivative is 6s minus 2. And let me mention that if you were to simplify what you had in your original quotient rule, it would match the answer I got for way 2. You don't need to simplify anything at the moment, and this we kind of lucked out. In this case, it would have been easier to divide first, because stuff cancels. But not all quotient rules are like that. For example, x squared minus 1 over x squared plus 1. I can't divide this. Well, I can divide it, but it doesn't simplify as easily. So what I could do to find the derivative is I could use the quotient rule. But if I'm going to use the quotient rule, I'm going to use u's and v's. U is going to be the one on top, and the derivative of x squared minus 1 is 2x. V will be the one on the bottom, x squared plus 1. And the derivative of x squared plus 1 is 2x as well. So to use the quotient rule to find the derivative, it's the low one, that's x squared plus 1. D high, that's the derivative of the top, that's 2x. Minus high, that's u, x squared minus 1. D low, that's the derivative of the bottom, which is 2x. All divided by low, x squared plus 1 squared. So using the quotient rule is really straightforward as long as you can identify the functions, find the derivatives, and put them together correctly. But again, in this case, there's another way I could have done that. This one does simplify. You can simplify this one by factoring. You can divide by factoring it. So if I would have rewritten this, oh no, you can't do this one by factoring. It's not a difference of squares. So that would be the only way you could do this problem. There's no other way to do this. And if you were to simplify stuff out, you'd get an answer that looks more neat or neater. But at the moment, you don't need to do that. You can leave your answer just like this. So a lot of the quotient rule and the product rule are identifying the functions and putting them together in the form. The last example I want to do is a combination of both. This is x squared, or x minus 1 times 2x squared minus 1 over x cubed minus 1. You can see that you're dividing two things initially. So when I write down the two things that I'm working with, I'm going to use u and v because f and g is taken. But my u is going to be what's on top. That's x minus 1 times 2x squared minus 1. My v is going to be what's on the bottom. That's going to be x cubed minus 1. Well, I can find the derivative of v pretty easily. The derivative of x cubed minus 1 is just 3x squared. But I have a little bit of a problem finding the derivative of u, because u requires me to use a product rule to find the derivative. I'm multiplying two functions of x together. So I could multiply them together and find the derivative, or I could use the product rule to find the derivative of u. It does not matter. It's actually easier to multiply those together, but because we're practicing the product rule, I'm going to use the product rule. So I'm going to call this one f, and I'm going to call this one g. So if u is x minus 1 times 2x squared minus 1, I can use the product rule to get u prime. The product rule tells me that it's the derivative of x, the derivative of f is x minus 1. The derivative of x minus 1 is 1. Derivative of the first times the second plus the derivative of 2x squared minus 1 is 4x, the derivative of the second, times the first. So u prime is going to be 2x squared minus 1 plus 4x times x minus 1. And you can simplify that a little bit. 2x squared minus 1 plus 4x squared minus 4x. And if I put that together further, I get my u prime. 2x squared and 4x squared is 6x squared minus 4x minus 1. That's the same derivative I would have got if I'd have multiplied it first and then found it. So now I can use the quotient rule to find this derivative for g. It's low, that's x cubed minus 1. D high, that's the derivative of my u, that's 6x squared minus 4x minus 1. That's low d high, minus high, that's x minus 1 times 2x squared minus 1, times d low, that's the derivative of the bottom, that's 3x squared. So what I have now is low d high minus high d low. And I divide it by the low squared, which is x cubed minus 1 squared. Again, once you get an answer that you believe is correct, you don't need to bother simplifying it further. So in this case, my derivative looks large, and I could do a lot to simplify it, but you don't have to. So that gives you an idea of how to use the product and quotient rules. Really, the hardest part about those things is identifying when to use them.